Hey guys, so in this video I'm going over the review that is set up similar to the assessment that you will have tomorrow, which is Wednesday, January the 23rd, I believe. So the first question that we kind of went over during class, choose the correct answer choice. The graph of a linear function f of x is shown below. So the first things first, we're going to find the rate of change of f of x, which is the graph. When I say a rate of change, I also am meaning the slope. It's the same thing. So what I want to do is come onto the graph and put a point where what I consider a pretty ordered pair, which means that there is no decimals. So 0, 5. Then I'm going to go and find a second pretty ordered pair. So I do not want to guess what the decimals are right there. That's why I'm going to look for one where the coordinate plane, there's an intersection of a horizontal and vertical line, which is right there in the blue. That is at 2, 4. Now, once I identify two ordered pairs that are 2 points on the line of the graph, I can find the rate of change in two different ways. One, I can count the rise, then I can count the run, or I can use the formula that we've been using, which is y2 minus y1 divided by x2 minus x1. Now, because all of the other ones we used this slope formula, I'm going to use the method of rise over run and counting it. So what I want to do is our slope or our rate of change is going to be rise over run. Well, how much are we either rising or falling first to get from the red dot at 0, 5 to the blue dot, which is 2, 4? We went down 1 unit. And because we went down, this is going to be represented by -1. So our slope is going to have a -1 in the numerator. Then we went over to the right 1, 2. So because we went over to the right 2, we have +2. So our bottom or our run is going to be +2. So this means that, and I'm going to write it down here, our slope or rate of change for f of x is -1/2. Then we go on to g of x. So g of x equals x divided by 2 plus 5. Now, we want it in the form y equals mx plus b. So we can compare the slopes or the rate of changes a little bit easier. So we've got to talk about how this can be separated out, the x divided by 2. Well, we're going to rewrite it over here so we can talk about it. What is understood in front of the x? If we multiply any number by this one specific number, you're going to get the same exact thing. You should have said 1, because 1 times any number is itself. Then what operation is in between this 1 and this x? Multiplication. So once we identify this, we can separate out that 1/2 multiplied by x. Now, why does this work? I know a lot of people were confused about how I did this in class. This is because there's also an imaginary one under this x. So it's kind of already understood. We don't write it, but if I come down here and put, let's say, 5. Well, if I want to write 5 in a different form, I could always put a 1 underneath it, because 5 divided by 1 is still 5. So it still equals the 5 that I originally put. So the reason why 1/2 times x is the same thing as x divided by 2 is because we can put a understood 1 underneath this x and get the same thing we started with over here. So 1 times x gives me x, and 2 times 1 gives me 2. So all of that to say that the rate of change for g of x is positive 1/2. So now we're comparing our rate of change of f of x is negative 1/2, and the rate of change of g of x is positive 1/2. We're choosing the correct answer choice. So the rate of change of f of x and g of x is 1/2. No, only one of them is positive 1/2. The rate of change of f of x and g of x is 5. Incorrect, neither one of them is 5. F of x is negative 1/2. Check. G of x is 1/2. Check. So our answer is C. And then if you wanted to, you can go down to D and also mark it out, because g of x, or the rate of change of g of x, is definitely not 2. So going on to 2. Find the rate of change using the table below. So for this one, all we're doing is going into our table and finding the ordered pair where x is 0, y is going to be 5, where x is 2. And let me color code this. Give me 1 second. So where x is 0, we're looking at the table and our y is going to be 5. So we're going to have 0, 5. Now for x equals 2, we're going to go to our table where x is 2, y is negative 3. So we're going to have an ordered pair of 2, negative 3. So then we're going to use our formula, which was y2 minus y1 divided by x2 minus x1. Again, doesn't matter what order you use, just got to keep up with which order you choose. So x1, y1, x2, y2. So I've got my negative 3 first. Subtract my 5 divided by my 2 minus my 0. So all I did was substituted in my x values and my y values. Now I'm going to simplify. Once I simplify, I get negative 4. So that is my answer. Now go on to B. B, I'm looking where x is 3. So I'm going to go to the table and If x is 3, y is going to be negative 7. I have 3, negative 7. And then I have also x equals 4. So x equals 4, my y value is going to be negative 11. So I have 4, negative 11. Again, using the same formula. Again, you can write it either way. So y1 minus y2 divided by x1 minus x2. So this is going to be my x1, y1. My 4 is going to be my x2. My negative 11 is my y2. And the first thing I want to put is my y1, which is negative 7. Subtract my second y value, which is negative 11, divided by my x1, which is 3, minus my x2, which is 4. So once you do this, you put it in your calculator, you figure it out, you get negative 4. And that is your answer as well for B. So for 3, we're going to use our table to answer the questions. So Sarah compared the function f of x equals 10x plus 13 to the linear function that fits the values in the table. What is the distance between the slopes of the two functions? So for this one, we're looking at slopes. We got to figure out the slopes of our g of x before we compare. So in between 0,13 and 1,16, we've got to figure out what the slope is. So I'm going to designate 0,13 as blue. I'm going to designate 1,16 as green. And go forward. So 0,13 and 1,16. So I've got to substitute those values in. I'm going to do 16 minus 13. And then I've got 1 minus 0. And I get 3. Yes, not bad. 3. Now, that is going to be substituted in to our slope-intercept form. Our slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept. So we're going to substitute this stuff in. We've got y equals 3x plus b. Now on the other ones that we reviewed today, we know how to solve for b. We solve b by choosing any ordered pair from the table and plugging it in for x and y. But looking at this table, it already tells us what our y-intercept is by one of the ordered pairs. When I say y-intercept, I am meaning where x is 0, y is a value. So looking at our table, we have where x is 0, what y is going to be. So we simply substitute that y value in on the table into the function. So now we know our slope and our y-intercept, so we can write our formula, and now we've got it. And now we can compare our g of x to our f of x formula. So looking at the slopes, we've got 10 and 3. How much distance are in between? So we're going to take the biggest number, subtract the smallest number, and we get 7. Next question is, what is the difference of the slopes when f of x is subtracted from g of x? So what we're asking here is, trying to use different colors as we go. So f of x slope is 10 and is subtracted from g of x, which is 3. So 10 is going to be subtracted from 3. Or another way that you can rewrite this is saying 10, I'm going to write it over here, 10, my bad, when 10 is taken away from 3. That's another way that you can say that question. So what we're going to do is first have 3, and we're going to take away 10 from it, or minus 10. Here we get negative 7. So there's your answer there. There's your answer for A. Now going up. For C, which statement correctly describes the y-intercepts of the two functions? So we're looking at our value that has nothing to do with the x. The one that will be by itself in the formula. So we've got 13 here, and 13 also for f of x. So we are going to choose A because both of them are 13. So what is the average rate of change from 1 to 3? So in between 1 and 3, we've got to figure out the order pair. So I'm going to choose, let's do a dark blue. So 3, it's going to be this dark blue. And then our 1 is already green. So our 1, 16. And our 3 was 322. So I'm going to find the slope, or the rate of change. So 22 minus 16 divided by our 3 minus 1. And when you do this, you're going to get positive 3. Number 4. Again, remember, go back and pause the video or rewind so you can copy down or hear my explanation again. Which function has the greatest y-intercept? Choose the best answer. So here we kind of get into the different versions of our slope-intercept form. So again, we're looking for y equals mx plus b. Well, in A, is there a b? Well, there doesn't look to be a b because there's nothing adding or subtracting off to the right side or anything adding or subtracting to this 3x. But if we wanted to add something to give that reassurance of seeing something there, could we not add 0? If we add 0, does it change the value? No, it does not. So we can do plus 0. Now our y-intercept for A is going to be 0. Now for B. B, we've got to do a little bit of extra work. B, we want it where y is by itself. So we're going to subtract 2x from both sides. So these cancel out, the 2x minus 2x. You're left with 3y equals negative 2x plus 12. Again, we're looking for y equals mx plus b, and we do not have the y by itself yet. Not quite. So because there visibly is no operation in between the 3 and the y, we assume that it's multiplication, or we know that it's multiplication. So the inverse operation of multiplication is division, so we can get rid of that 3. Now, a lot of teachers do the next step differently. I like to divide the whole side using one fraction bar due to the fact of helping you remember to divide every term on the other side. So what you do on one side, you got to do to the other. 3 divided by 3 is just 1, so it goes away. And now you have a negative 2 divided by 3. That stays as a fraction. And then you have a 12 divided by 3. 12 divided by 3, hopefully you know it's 4. Now we've got it in slope-intercept form. Now we can identify that our positive 4 will be our b, or will be our y-intercept. So y-intercept is positive 4. And our c. Our c kind of takes it back to what we've been used to. Again, y-intercept is where our x value is 0 and our y value is going to be a value. So starting at the origin, looking at our y-axis, which is always our vertical axis, where does the line cross this axis? Hopefully you can identify that it's right here. So we're going to count up 1, 2, 3, 4, 5. So our ordered pair would be 0, 5. And our y-intercept, if you want to just have a number, is 5. So now we're comparing 0 to 4 to 5. And we're asked which has the greatest y-intercept? And the answer is C. For number 5. Number 5, the table below shows the average The table below shows that the average diameter of a pupil in a person's eye as he or she grows older. What is the average rate of change in millimeters per year of a person's pupil diameter from age 20 to age 80? So again, don't overthink it. It says from age 20. So kind of pause there as soon as you hear from age 20. And you're going to go into the table and get that order pair. So you've got 20 and 4.7. Then you have a 2 age 80. So then you're going to come in here and look at just when the age is 80. So you've got 80 and 2.3. You're going to set up your slope intercept. So I'm going to do 2.3 minus 4.7 divided by 80 minus 20. And this you should get negative 0.04. And that will give you number 4 as the answer choice. For number 6, use the table below to answer the following questions. So for A, we've got Joe compare the functions f of x equals x plus 6 and the linear function that fits the values in the table above. Which statement correctly describes the slope of the two functions? So we're looking for the slope. We're also going to go ahead and identify what the slope is for f of x, which is the function that's given. So what is understood if there's not a number in front of a variable? It's 1. So there's an understood 1 right there in front of the x. So we've got f of x equals 1 times x plus 6. And our slope is going to be that 1. Now for our table. The table, we got to find our slope. So we've got 2.5. And then we've got 3.7. I'm going to set it up. 7 minus, I'm sorry if I don't get the exact colors. Should have thought about that. 7 minus 5 divided by R3 minus R2. So when we do this, we should get R2. Now, we also, well, we can stop there. Not bad. So our slope will be substituted into our slope-intercept form. So we will have this left over, y equals 2x plus b. So now we're comparing our 1 and our 2, which are our slopes. So the slope of f of x and g of x are the same. That's incorrect, so we can mark it out. The slope of f of x is 2 times larger than g of x. So our f of x was 1. Our g of x was 2. So the slope of 1 is 2 times larger than 2? No, incorrect. The slope of g of x, which is 2, is 2 times larger than f of x, which was 1. Correct. So C is our answer. Again, if you want to keep going, you can. The slope of 2 of g of x is smaller than the slope of f of x, which is 1. Well, 2 is bigger than 1, not smaller than 1, so D can't be an answer either. Now for B, what is the distance between the y-intercepts of the two functions? The y-intercept of f of x is already given. It's 6. So y-intercept. We've got to talk about how to find our y-intercept for g of x, though, the table. Because it doesn't show you where x is 0, what y is. So we're going to plug in some values. I'm going to go with the 2, 5. So I'm going to use this order pair over here in the table. So where 5 is, I'm going to substitute in for the y equals 2, and then I'm going to put 2 instead of x plus b. And I'm going to solve for b. So I'm going to distribute that 2. I get 5 equals 4 plus b. Because that 4 is positive, I'm going to subtract 4. Subtract 4. They mark out. And I get 1 equals b. So we're comparing our 6 of f of x and our 1 of g of x. So what is the distance between the y-intercept of the two functions? So I put my greatest value, which was 6, minus my smallest value, which is 5.